Hello Precalculus, I'm back with some videos on using trigonometry when we don't necessarily have right triangles. So to introduce that, I'm going to give you one where you actually have to use a right triangle to solve this. This one's kind of an out of the blue, don't even have to use trigonometry to figure out the value of A and C. Here's why. You've got variable expressions for the angles, and you've got variable expressions for the sides. Now, since the same variable is applied to both angles, you could just use the triangle sum to say that 11a minus 2 plus 6a plus 7 plus 90 degrees equals 180. Or if you want to do a shortcut, you could say because this is 90 degrees, these two added together have to add up to 90. So you could say, cross that out, set it equal to 90. Yeah, so then 17a plus 5 equals 90 degrees. Solve it like it's a regular equation like you've been doing for years now. 17 actually goes into 85 evenly, 5 times. 5 times exactly. Okay, there it is. There's the value of A. The value of C can be found by using the Pythagorean theorem. C squared plus C plus 7 squared must equal 3C minus 2 squared. So just using regular old algebra, expanding polynomials that are squared, if they're binomials, 2 terms, you can square the first, square the last, and then double the first times the last. 7c times 2 is positive 14c. And then you can use that same shortcut over here. Square that, 9c squared. Square negative 2, it turns into a positive 4. Double 3c times negative 2, that's doubling negative 6c. All right, at this point, you guys can formulate like terms on either the right-hand side or the left-hand side, and probably we're going to have to use the quadratic formula or factoring on this. So what I'm going to do is I'm going to move everything over to the right. So this comes out to be 2c squared. So I'm going to subtract 2c squared right away. And then opposite operations here. I normally move things to the left-hand side of the equation, but this case is a little bit different because I want to keep a positive in front of the c squared. So 0 equals 7c squared minus 26c minus 45. So at this point, you guys can move a little bit closer. Since it's digital, we don't have to keep social distancing here. I want to show you guys some maybe tricks if it is factorable. You know that 7c squared, the only way to achieve that through reverse engineering of the multiplication process, going from a 3-term polynomial back to a c plus 7 times a c plus 7, is you're going to have to take 7c times c, okay? Now, we should probably think to ourselves, what multiplies to give us this very large number and adds up to get the middle? But maybe guess and check is our best bet, all right? So 45, you got 15 times 5, but this is going to be, or not 15 times 5, 15 times 3. That's going to be way too big of a gap when we expand it, so that's not going to work. You could try 5. Let's see, 5 times 9. 63 and 5 don't add up, but if I were to switch them around, the 5 here and the 9 here, this is going to be negative 35 plus 9. That gets the negative 26. So this was me guessing and checking factoring. That might not have been helpful for you at all. But keep in mind that what you can do is guess and check. One of the other options would be to say, what multiplies to give me 7 times 45, which is negative 315, and adds up to give you negative 26. So if you go into a calculator that has a table, you could take negative 315 divided by x, look at all the x, y coordinates, and you'll find that negative 35 times 9 satisfies both those conditions. Multiplies, adds up. So this is going to be negative 9/7 and positive 5. Because C represents a side length, the negative is a no-go. So C equals 5. All right, now you may be wondering, what was the purpose of me even giving you this in the middle of right triangle trigonometry? I just wanted you guys to keep in mind that these are several basic rules of right triangles. All the angles add up to 180. The sides are connected with the Pythagorean theorem. Don't forget those very fundamental things as you incorporate more and more sine, cosine, tangent, and possibly the other three. So there's number 1. Number 2 on the notes, this is where the real new content comes into play. So I've got a non-right triangle, and I need to solve for all the missing angle measures, angle Y, angle Z, and I want to figure out what this side is. Now, I probably could have just said, solve for angle Y, solve for angle Z, and we're really looking for the measure of angle Y and the measure of angle Z. I probably could have just said XZ for the segment length, but I called it Y anyway because a lot of times it is appropriate. It's commonplace to say that opposite capital Y is lowercase y. So just throwing that out there. You'll see that quite a bit from here on out. Now we really don't have a means to do sine, cosine, or tangent of 25 degrees because there's no right triangle to work with. So one strategy is to drop what's called an altitude from the top vertex of the triangle to its base. And drop it at a 90-degree angle so that, now we've created a right triangle here, and we've created a second right triangle over here. And if you want to apply variable measures, you could say that this right here is one unknown, and this right here would be the other unknown. Those two added together would give us y. So I don't know. I don't think we should use x or z because there are already angles over here. Let's just use a and b. So we'll say a represents this length here, b represents this length here, so that a plus b is equal to y. Now, this is the place where we want to start because anytime you have a one side length and one angle measure of a right triangle, you can solve for all the other missing parts. So I can solve, I know this is 90 degrees, so 25 plus 90 plus this unknown angle here has to add up to 180 degrees. So if you plug in 65 degrees here, it works. And then we can also use the fact that this length here can be found by using, h for height. I can't use a for altitude because I already used it. So here's what we got. Sine of 25 degrees, remember, equals the opposite side, h, divided by the hypotenuse of this particular right triangle, 18. And solving for h is going to be helpful now for solving the other right triangle. I don't want to jump ahead though. So h equals 18 times the sine of 25 degrees. So to approximate this value, make sure we are in degree mode on whatever calculator we're using, and you will have to use a calculator on these from here on out to get accurate measures. It's 7.607 units in length. So I'm just going to take out this h right here and call this 7.607. It's not a measurement that was asked for, but it's a measurement that will be helpful in solving those parts. So now angle or letter A, which is part of this line segment, we can now say its relationship with 25 degrees is adjacent leg. So cosine has the adjacent leg and the hypotenuse. So we can do cosine of 25 degrees equals A over 18. And again, multiply 18 to both sides, and you've got A. A is approximately 16.314. Now, what we can do right off the bat is two things. One, we can say the sine of z, so we don't know what z is. The sine of angle z is equal to the opposite side, which is an approximation. Technically, we're approximating this. 7.607 divided by 25. And if you guys recall from before Christmas break, we had to do is do an inverse sine applied to that ratio on the right-hand side. So if we apply the inverse sine to 7.607 divided by 26 in degree mode, it gives us 17.012 degrees is the value of sine. So we've got one of our angle measures, at least we have an approximation of it, which means if we have two of the three angles of a triangle, we can kind of just say, well, we're looking for y in its totality. We don't need this little sliver right here, so we can actually say that 65 was not needed information. We can now just say 180 minus 25 minus 17.02012 is going to equal the measure of angle y. So we'll use our handy dandy calculator to make that happen. 137.988 degrees. All right, now we are almost there. You've got several options to find. Let's see. We need y in its total, which means we need this length b here from the altitudes drop to z. We could use the Pythagorean theorem to say that 7.607 squared plus b squared equals 26 squared. So if I just erase this work here, I'm sure you got that down already. 7.607 squared plus b squared is equal to 26 squared. Get b by itself and you've got your length. Add them together, you get y. Or you could use another trig function. You could say, hey, the cosine of z, which is 17 now, 0.012, is equal to b divided by 26. Now, I don't know about you guys, but trig I can do it easier and quicker on the calculator. For some reason, this just seems cumbersome, unless you do some multiple steps in your head. What I mean by that is, what if I subtracted this to both sides? Okay, so subtract it from both sides. It's gone now. And then square root. If you can visualize that this is the calculation that I just plug into the calculator right away, it's not too big of a deal. But I will say, if you're an energy conservationist, I don't know if that's the right way to say that. If you like conserving, the amount of time you're spending here, I'm not pushing many buttons to get this first one. And if I make a mistake, it's probably going to be easier to spot it using this one than that one. I get 24.862 for the b value. And if I do it on the other one, I should get somewhere pretty darn close to that. I actually get the exact same answer when rounded to the nearest thousandth. Same thing. All right, so then, to get xz, or the value for this little y here, I add 16.314 plus 24.862. 41.176. We didn't get a unit measure, but you know, it would be just regular units and not units squared or something like that. Okay. There we go. I did have a third example in line, but I think this probably should cover it. If you're being asked to find the area, wait, let me check this out first. Let me freeze this so you guys aren't getting a headache from me scrolling up and down. Did I ask for area? Nope, I didn't ask for any area, so I'll save that for the next video. I will tell you, you need to make one adjustment on the digital document of your homework. I just forgot to give you guys a piece of information. So this was 15 degrees. Actually, you know what? Let me think about this. Let me hunt some information down really quick, because I gave it to people in class, but now I'm kind of forgetting which one I... This won't take too long. Just bear with me. We gave that angle measure a 125 degree measure. All right, so sorry for being a little disjointed on this video, but you got examples 1 and 2. I think you'll be okay without number 3. If not, please contact me, and I'll do my best to explain. Thanks for watching.